Imagine a world where thoughts translate into action without the need for physical movement. How close are we to this reality? Welcome to the fascinating world of brain-computer interfaces, or BCIs, a technology that enables direct communication between our brain and computers. The concept of BCIs may sound like science fiction, but they are increasingly becoming a part of our reality. These interfaces can read electrical signals from the brain, decode them, and then use these signals to control a computer or other digital devices. It's like having a conversation with a machine, only without words. Now, this is where artificial intelligence, or AI, steps in. AI, with its ability to learn from and make sense of massive amounts of data, is playing a pivotal role in shaping the future of BCIs. It helps in improving the signal processing and analysis of BCIs, making them more efficient and accurate. AI algorithms can sift through the noise of brain signals, picking out relevant patterns and translating them into meaningful actions. This collaboration between AI and BCIs is also making these interfaces more accessible and affordable. AI advancements are reducing the cost and complexity of BCIs, enabling more people to benefit from this revolutionary technology. There are different types of BCIs, each with their own characteristics. Some are invasive, requiring surgical implantation into the brain. Others are non-invasive, using sensors placed on the scalp to read brain signals. And then there are semi-invasive BCIs, which are implanted on the surface of the brain but not within it. The potential applications of BCIs are vast, from assisting those with disabilities to creating mind-controlled virtual reality experiences. The possibilities are as boundless as our imagination. But with these advancements also come ethical and philosophical considerations. Issues like privacy, security, and free will are being brought to the fore as we navigate this new frontier. As we tread into the realm of the future, AI is becoming a crucial component in developing brain-computer interfaces. In the next scene, we'll delve deeper into the mechanics of BCIs and how AI enhancements are revolutionizing this field. Stay tuned. How do these brain-computer interfaces work, and where does AI step in? Well, let's dive right in. Brain-computer interfaces, or BCIs, are categorized into three main types: invasive, non-invasive, and semi-invasive. Invasive BCIs are implanted directly into the brain during surgery. They provide the highest quality signals, but with the associated risks of surgery and long-term stability. Non-invasive BCIs, on the other hand, are worn like a cap and capture brain signals from the scalp. While they are safer and more comfortable, they offer a lower signal quality. Semi-invasive BCIs strike a middle ground, mounted on the surface of the brain but not penetrating the tissue. Now, enter the realm of artificial intelligence. AI can enhance BCIs in several ways, especially in signal processing and analysis. When a BCI captures signals from the brain, it's a bit like trying to listen to a conversation in a crowded room. You have all these neurons chatting away, and you're trying to pick out a single voice. AI algorithms are like expert eavesdroppers, helping to filter out the noise and isolate the relevant signals. But there's more to it. AI can also decode these signals, interpreting them into commands or feedback. Imagine the brain as a foreign language speaker and AI as the translator, turning the brain's language into something a computer can understand and respond to. This decoding process is crucial for the effective functioning of BCIs, and it's where AI truly shines. Furthermore, AI is driving advancements in BCIs, making them more affordable and easier to use. Machine learning algorithms are becoming better at interpreting brain signals, reducing the need for expensive hardware. They're also making BCIs more user-friendly. Instead of having to manually calibrate the system for each individual user, AI can learn from the user's brain signals and adjust the system accordingly. So there you have it. AI is not just an enhancement to BCIs, it's a key ingredient that's making BCIs more accessible, efficient, and effective. With AI's advancements, BCIs are becoming more affordable and user-friendly, breaking barriers in technology. What if you could control a computer or a wheelchair with just your mind? With BCIs, this isn't just science fiction. Brain-computer interfaces, or BCIs, are shaping up to be the next frontier in human-computer interaction. These devices, which connect our brains directly to computers, are poised to revolutionize a wide range of fields. Let's consider the field of rehabilitation. Imagine a person who has lost the use of their limbs due to a spinal cord injury. With BCIs, they could potentially regain some of their mobility. A BCI could be used to interpret the signals from their brain and translate them into movements of a prosthetic limb or a wheelchair. This could drastically improve their quality of life, giving them a level of independence that might have seemed impossible before. But the potential applications of BCIs go beyond physical rehabilitation. They could also be used for mind control. No, not in the sinister sci-fi sense of the term. Rather, BCIs could be used to control things like drones or other devices just by thinking about it. Imagine the possibilities. You could potentially fly a drone to take aerial photos or control a robotic arm to perform complex tasks, all with just your thoughts. BCIs could also revolutionize the field of virtual reality. Instead of using a controller or a keyboard, you could navigate virtual worlds using your mind. This would make the experience much more immersive, as you would be able to interact with the virtual environment in a much more natural and intuitive way. These are just a few examples of the potential applications of BCIs. The reality is that the possibilities are as vast and varied as our imagination. From helping people with disabilities lead more independent lives to changing the way we interact with technology, BCIs are poised to usher in a new era of human-computer interaction. The potential applications of BCIs are as limitless as our imagination. But with great power comes great responsibility. What are the ethical implications of this technology? As we delve deeper into the realm of brain-computer interfaces, or BCIs, we must also explore the ethical and philosophical dimensions that accompany such advancements. When we talk about BCIs, we're venturing into a territory where technology directly interfaces with the human brain, and that brings up some critical questions. Firstly, there's the issue of privacy. With BCIs, thoughts are no longer confined to the realm of the mind. They can be read, interpreted, and potentially manipulated by external entities. This raises concerns about who has access to this data and how it could be used. Could your innermost thoughts be sold as data? Could they be used against you? These are questions we need to consider. Then there's the matter of security. As with any technology, BCIs are not immune to hacking. The concept of someone gaining unauthorized access to your brain is a disturbing thought. Ensuring robust security measures are in place to protect users from such invasions is of paramount importance. The third issue is that of free will. If a BCI can read and interpret our thoughts, to what extent can it also influence them? Could a user be manipulated or controlled through their BCI? This brings us back to the age-old philosophical debate about free will versus determinism, but with a modern twist. Moreover, there are concerns about equality and accessibility. Who gets to benefit from this technology? Will it be used to widen the gap between the haves and the have-nots? Or will it be a tool for leveling the playing field? These are just a few of the ethical and philosophical dimensions we need to consider as we continue to explore the potential of BCIs. It's a brave new world, and with it comes a whole new set of ethical conundrums to ponder. As we continue to develop and use BCIs, these ethical considerations will become increasingly important. So what does the future hold for brain-computer interfaces? Fasten your seatbelts as we journey into the not-so-distant future, where brain-computer interfaces, or BCIs, could redefine our reality. As technology advances, the possibilities for BCIs seem to be expanding at an exponential rate. Let's paint a picture of this exciting future. Imagine a world where we can connect brains directly to each other. This could open up a whole new realm of communication, doing away with the limitations of language and physical proximity. We could potentially share thoughts, experiences, and emotions directly, creating a level of understanding and empathy previously unimaginable. This is the prospect of brain-to-brain interfaces, a possible evolution of BCIs. But let's take it a step further. What if we could integrate our brains with artificial intelligence? This might sound like science fiction, but it could become a reality sooner than we think. The integration of the brain with AI has the potential to supercharge our cognitive abilities. We could process information faster, recall memories with perfect clarity, and perhaps even access the internet directly through thought. Imagine learning a new language or mastering a musical instrument in the blink of an eye. The possibilities are truly mind-boggling. Of course, these future scenarios come with their own set of challenges and ethical considerations, as we've discussed earlier. Still, they illustrate the transformative potential of BCIs. As we continue to push the boundaries of technology and neuroscience, we might just unlock a new era of human evolution. In conclusion, the future of BCIs is a thrilling prospect. It's a journey into the unknown, full of potential and promise. Whether it's brain-to-brain connections or the integration of our minds with AI, we're looking at a future that could reshape how we interact with the world, and even with our own minds. The future of BCIs is a thrilling prospect, potentially reshaping how we interact with the world and even with our own minds.